Hello, welcome to another exciting example of Mr. Wernau does your homework. Alright, so with this example right here, this is question number 1 on our little worksheet for today. We are asked to integrate integrate 2x over x minus 4. Now, you can try U-Substitution and it will fail. So this is a case, a very rare case, where we're actually going to use division. Even though we normally use it only when the degree on top is bigger, in this case right here, we're also going to use that skill as well, because we can't split our integral like it is. So we're going to take this 2x and we're going to divide it by this x minus 4. And of course, x needs to be multiplied by 2 to get that 2x to cancel. And that's going to give us 2x minus 8. When we subtract, this cancels, but that becomes a plus 8. So our new integral becomes this 2 plus 8 over x minus 4 dx. Now what you'll notice is that we're going to be talking about a lot of different integration techniques right here. So this one right here is not that hard to do. The antiderivative of 2 is just 2x with respect to x plus, but over here we got a U-Substitution. So my u is going to be this x minus 4. Du is going to be dx. I mean, it's good, we're not multiplying or dividing by anything. So we're left with this 8, and remember, this just became u for us, and the antiderivative of 1 over u is just natural log of u, but our u here is this x minus 4, and then don't forget your constant of integration right there. And there's our answer. Alright, so let's take a look at another one. Number 3 in our homework, x times e to the negative 3x dx. Now you might recognize this one as our integration by parts, and that's good. So we need to determine, remember, integration by parts, the antiderivative is going to be uv minus the antiderivative of v du. So we need something to be for u, and we need something to be for dv, of course. You might recall in one of our other videos, we always said u should be the algebraic function because its derivative kind of goes away nicely. So I'm going to let u equal x here, and my dv be this e to the negative 3x dx, the rest of it. When we integrate, we get du becomes dx. Now this one we got to solve for v. So v becomes, now remember this is a quick U-Substitution, so we know our u is this 3x, we're just going to divide it. So this becomes negative 1/3 e to the negative 3x. And we just sub it into our problem, u times v, so it's going to be u times v, so it's going to become negative 1/3 x times e to the negative 3x minus the antiderivative of v du. So if I factor out that 1/3, that becomes a plus 1/3 e to the negative 3x dx. And now we want to start, just like I said, using integrating much faster. I know this is my u right there. So my shortcut said I'm just going to divide by it. So I'm going to divide by du. So therefore my du would become negative 3 dx. Give me dx is du over negative 3. So we're going to divide by negative 3 for our final answer. So we're going to bring this down, negative 1/3 x e to the negative 3x. I'm going to multiply this 1/3 by this negative 1/3, so it becomes minus 1/9 e, and remember this is u, just u, which is negative 3x plus c1. And there's our antiderivative right there for our integration by parts. Alright, the next we're going to take a look at is, this is an oldie but a goodie. This is not really one of our rules, this is not one of our new rules, but we've seen this before. We haven't seen it in a while. So secant of 4x dx. Alright, so you can use U-Substitution here. So we know that u is going to be 4x. Du is 4 dx. So dx is, of course, du over 4. And that's just telling me I'm dividing by 4 in my final answer there. So the antiderivative of secant is natural log of the secant of u, which we said u is 4x, plus the tangent of u, which again we said was 4x, plus C1. Now don't forget we are dividing by 4, so don't forget about that. And there's your final answer right there. See, these go pretty quickly. All right. Let's see here. Let's take a look at one where we have to use one of the arc trigs. So let's look at number 8. So number 8 on your homework, or if you're just watching this as some practice, 1 over the square root of 2 minus 2x minus x squared dx. Now, of course, you're always going to try U-substitution, but my du would be this negative 2 minus 2x, and that doesn't cancel with anything. So we're left with, like I said, arc trig or one of our other rules. So this looks like it might be arc sine. Remember, arc sine is going to be u over a. So we will need to complete the square here. So I'm going to go ahead and complete the square. I'm going to do that off to the side here. This is a tougher one. So I'm going to reorder it. Negative x squared minus 2x plus 2. You have to factor out that negative. This becomes x squared plus 2x plus a blank space plus 2. That, of course, becomes a plus 1 because if half of 2 is 1, we square root that. Be careful. We have to fix it by adding something. But remember, here we're actually minusing 2. See, normally we would say minus 1. But because of negative, that means we're really minusing 1. So we have to add 1 to that side right there. And writing in the order, because remember arc sine is really, what is that? It's really a squared minus u squared. So I'm going to switch those around, and we can get 3 minus x plus 1 squared. So my new integral becomes 1 over the square root of 3 minus x plus 1 squared dx. So we need u and a. So we know a is just going to be the square root of 3. U is just x plus 1. Du is dx. Remember, you want to check this. We're good. So we're going to be left with the arc sine of u, x plus 1 over a, which is the square root of 3. And then don't forget your constant of integration right there. We haven't seen one of those in a while. That was kind of a nice little surprise. And let's keep on going on with this, these arc trig stuff. Number 9. Although this is a little bit different one, you'll see. The arc tangent of 3x dx. Now you gotta be careful with arctangent. We do not know this. We don't know the antiderivative of arctangent. We know its derivative, but we don't know its arctangent. Now sometimes people say it's just 1 over 1 plus 9x squared. No, that's the derivative. Scratch that out of your head. We don't know the antiderivative. So the only way we can solve this one is, but because we know the derivative, we can actually use integration by parts, because I know its derivative. So I'm going to use parts for this one. Parts is one of those like, you know what, I don't know its antiderivative, but I do know its derivative. You can use integration by parts. So integration by parts says we can have u and we have to have dv. Now the question people always ask, well, which one are you going to let be u? Well, u is the one that you know the derivative of. dv is the one you have to take the antiderivative. Well, I'm not going to put arctangent here because I don't know its antiderivative. It would make no sense. So my arctangent has to be here. Has to be my u. Its derivative, I know, is going to be 1 over 1 plus 9x squared. Don't forget to multiply by 3 dx. Now dv then, well, that's going to be my dx. This is dx. So v is just going to be x. And when I use my rule, uv minus the antiderivative of v du. So this is going to become x arc tangent of 3x minus the antiderivative of v du. And if I just multiply them, I'm going to get 3x over 1 plus 9x squared dx. So we're still not done, because I still have to integrate this, but this one's not so bad. I can actually use U-substitution here, because the derivative of 9x squared is just going to become 18x. Those x's will cancel. So I can go 1 plus 9x squared. Du is 18x dx. Dx is du over 18x. And again, like we said, those x's are going to cancel, and we're going to divide by 18. So I can start this out. My new answer, x arctangent of 3x minus, I still have this 3 on the outside, 3 over this 18. Now be careful, this is really saying 1 over u, which is just the natural log of 1 plus 9x squared plus c1, and you can reduce that if you feel like it to 1/6. And there's our antiderivative right here. Very easy to do. Alright, go to the next video. We're going to take a look at another example of when we have two transcendental functions. I'll see you then.